In this video, we're going to see using the Luminos.AI Data Science Library and API functionality to perform some demographic bias testing. The environment we're looking at, the window we're looking at here, is a Jupyter Notebook, which is a common environment for data science teams to use for data analysis. And we're going to be looking at Python scripts to hit our data science libraries. So the first thing we're going to need to do is just import the libraries, including these last two lines are the Luminos fairness and bias testing functionalities. So that's going to take just a second. And then we'll import a test data set. So in this case, we're pulling in a CSV file, or comma separated value flat file, of the output of a binary decision algorithm. And in this case, we can see in the columns in this data that we're looking at include some demographic characteristics, male, female, white, Asian, Hispanic, and black for racial characteristics. And we have a match score, which is going to be our target value, and we have an admit, which is our ground truth or comparison value. So, for example, the algorithm that was behind this data set was deciding some positive or negative decision based on these individuals, and we know their demographic characteristics, and so we can examine whether they're being treated unevenly. So now that I've got my data set, I need to set a couple of simple parameters, basically to tell the model which labels for race and gender I expect to see and what the control group is going to be, what kind of model it is. We create the bias tester object, and we're going to run one very specific test called an AIR test, or an adverse impact ratio test. So that's it. We ran the test, and you can see the output of that in this table. We have 3 tests for race, each against the baseline, and 1 test for gender, male against female. And you can see that our adverse impact ratio for gender bias is quite close to 1, which is actually our goal. The adverse impact ratio for the 3 racial tests is somewhat lower than that. They're still above our 0.8 ideal target, but we can examine a number of different attributes of the testing just from this table. And this is the kind of thing a data science team would want to examine to understand the performance of the model that they've got. This is a fairly specific detailed test, but I'll show an even simpler version is using our API functionality. If you just import the entire suite, you can run a battery of tests with a single command. And so this next one, we're going to import the API. We're going to update a couple bias test parameters because we have some new tests to run. And then we're going to run this one command, which imports all that same data and attributes and produces a variety of outputs in a beautifully formatted HTML report. So we're going to run those tests, and that's going to take just a couple seconds. At the high level, we can see we got a flag that says we didn't actually pass our battery of tests, so there are some concerns, but we don't have any errors, so that's good. And if we run this display HTML function, you can see that the API returned not only numbers, but actually a fully formatted HTML report with the contents of the analysis that we did. So you can see our color coding here. You can see a summary dashboard for all the different tests that we ran, including that adverse impact ratio that we just looked at, but there's a number of other ones that we want to look at. And from the color coding, we can see that our gender bias is indeed pretty solid. The model's output is pretty balanced between males and females, but the model's output is not balanced in the way that it's treating other races besides white. And so this is being flagged in a couple of different tests, and so you can kind of get an overall picture of 1 or 2 errors might be satisfactory as long as your main parameters are in place. But if you are failing a number of parameters, then there's pretty good evidence that there's a model bias. So we can look at a number of these things. Again, this report is HTML programmatically generated by the API dynamically with the results. And so you get not only boilerplate text that tells you, for example, what is this test used for and by whom and what sort of values would you like, but you also get some really nice explanatory text, like for the adverse impact ratio test, a score of 8.25. 0.825 means for every 1,000 white candidates who have a positive outcome, 825 Asian candidates have a positive outcome. And so the report that we're generating includes English comprehensible and legally valid language in addition to the technically valid, statistically robust bias testing. So we'll scroll down through here. There's a number of different tests, and they all have their own explanations, their own tables. Of course, your team may go back and tune up their models if they have you get a new set of data, or you're tuning the parameters, or you're trying to increase the representativeness of your training set. In this case, I'm going to update my parameters. I'm going to rerun this test suite using a slightly different set of data. And because our gender bias was in pretty good shape last time, I'm going to run this test only on racial characteristics. We're going to run it again, and we'll look at our final result here. And you can see overall, we're all in the green here. So we're now passing all of our tests across the board, and we have a model that is suitable for production.